Alright, ladies, we're going to do this video. We're going to make it fast, quick, and dirty for you. So, first, we're going to have some trig identities to work on. Take a screenshot of this, pause the video, write this down. You've got it in your email. These are the things you need to know to do trig identities. So, take a look at those. We're also going to talk about functions. Language, I called this a relation today. Anything that takes an element X in a set D and maps it to an element Y in another set. I would have called this R for range. But this is called a relation. The book we're going to use calls this a correspondence. The idea, though, is that it's a function, that correspondence or relation is a function. If from a set D to a set E, there's a correspondence that assigns each element X of D exactly one element Y of E. That's the idea, that every element in the domain goes to exactly one element of the range. So, like I said, we see that here with the vertical line test. We're going to go back to that last slide in a second, but you can check that definition with the vertical line test. The graph of a set of points in a coordinate plane is the graph of a function if every vertical line intersects the graph in at most one point. So we've got this visual test. I've got an XY plane here. This here is a function. Excuse my poor drawing. But I know it's a function because everywhere where I draw a vertical line, it only hits the graph once. Cool? Alright, some other notation back to this previous slide. What I like about this slide is that if you have an element A in the domain, in the range it goes to a value called f of A. If you have a value x, it goes to a value f of x. If you have a value z, it goes to f of z. In this case, f of w is also the same value as f of z, and that's fine. Notice z isn't going to two different values, w is not going to two different values, just that this value can be gotten at, or can be got, I can't speak, in two different ways. Cool? So, but I like that notation that we have a point A, and we have a point, its y coordinate is f of A, and we've got a point X, and its y coordinate is f of x. Good? That's an important idea. Some other notation. When are functions increasing versus when are functions decreasing versus when they're constant. Here's another good slide to kind of stop and take a picture of, get the meaning, maybe not the language. All it's saying is we can talk about a function increasing on some interval if for every x on that interval, whenever the x coordinate is smaller than another x coordinate, the y coordinate of the small x coordinate is smaller than the y coordinate of the bigger. So that's what we're saying. It's increasing because this point here is below that point there, and that's true for this entire function. Notice it doesn't have to be a linear function. It can be, you know, something like an exponential function or something like that. Decreasing is a similar definition, but it just talks about how this x coordinate here is smaller than this x coordinate here, but the y coordinate here is higher than the y coordinate down here, and that's what makes this a decreasing function. And then if there's no change at all, we say that the function is constant, and it can just be constant on an interval. It doesn't have to be constant the whole time. Okay, one last thing, some notation that we will learn, new notation. Domain, range, intervals. So you might be used to seeing this. X is greater than or equal to 2. Awesome. So if we were to graph that on a number line, we would have a 0 here, 1, 2, and then 3, 4, 5, 6, 7, 8, right? Just a bunch of numbers up here. And we would put like a closed dot here, and then we'd extend it that way. Good, I hope that's all review. This is called set builder notation. This is called interval notation. It starts at 2, and it goes forever towards positive infinity. So I use, well, not I, this is how we use interval notation. This is an interval. The bracket means can equal, and the parenthesis means can't equal. Cool? So if we try another example, how about x is between 10 and -3, but it can equal -3. So we would read this, -3 is less than or equal to x, which is less than 10. So again, if you think about it from a number line, we'd have -3 here, we'd have 10 here, 0 is somewhere about here. We would do a closed circle here, we would do an open circle here, and x could be any value in between. The interval would look like this. It can be -3, so we put a bracket. It can't be 10, so we put a parenthesis, and it's all the values between there. We wouldn't write it that way. We'd clean it up and just have it closer. Good? Last bit, if we are talking about this direction, so if we had something like this, an open circle here, but we could also have a closed circle like this. The direction to the left we call negative infinity. The direction to the right we call positive infinity. Good? Call this, I don't know, a value 5. Call this a value of 4. This would be a comma 4. Can't be 4, so parenthesis. This would be a 5, and it can equal 5, so a bracket and a parenthesis. We want to say it's these two intervals together, so we use a U for union, which I think you may have seen in your study of sets and IB math. All right, I have no idea how long that video is, but that's what we'll be working on tomorrow. Thanks, ladies. Have a great day. Peace.